the periodic table. In this chapter, you will learn about certain groups, group 1, group 7, group 8, and properties of the transition metals. So what is a periodic table? First, it's a tabular arrangement of elements in rows and column. Like example, when we arrange the element in rows, these are the rows, and in columns, it will form one table, and this table is refers to periodic table. And you can see, I'll show the periodic table. But what's the advantage of using a periodic table or arranging the elements on the basis of their atomic number or the basis of the repetition of properties? So this tabular arrangement of element in rows and columns and highlighting the regular repetition of the properties. Like when we find elements, they have a similar properties, and this table is simply termed as periodic table. Why periodic table is important? But before that, what, like the periodic table is why it's the most useful thing for the chemist, because using this you can identify the properties of different elements. Even though if, for example, a newly discovered element is there, so you can predict the property of that element by using a periodic table. So this is a modern periodic table. You can see before pre-periodic table, there was no arrangement, so it was a mess, no organization of the elements. So this is a periodic table or the modern periodic table. You can see this modern periodic table. These are the columns. What we call these columns? We call these columns as groups. So the column here is refers to group. And what is the meaning of the group? The meaning of a group here refers to, it shows number of electron in the valence shell or the last shell. So how many electrons are there in the last shell? That shows a group number. So you can see group 1. So these are group 1 element: lithium, sodium, potassium, rubidium, cesium, francium. So what is the meaning of this group 1? It means whenever I draw the last shell for these elements, the last shell of all these elements, how many electrons will be there in the outermost shell? They all have 1 electron in the outermost shell. Same thing, this is group 2. So it's group 2. How many electrons will be there in the last shell? Whenever I draw the last shell for these elements, it will always have 2 electrons in the last shell. Group 3, what it shows group 3? Group 3 will have 3 electrons in the last shell. Group 4 will have 4 electrons. 5 will have 5 electrons. Group 6 will have 7 electrons. And this is also called group 8 or 0 group. Group 8 it's having a complete shell. That's why it is also known as 0 group. So basically what group number represent? The group number represent number of electrons in the valence shell or the last shell. Then horizontal rows are refers to period. So example, this is the first period of a periodic table, and the first period consists of only 2 elements, which are hydrogen and helium. What is the meaning of the period? Period means the number of the shells how many shells are present in an atom. That refers to a period. So if this is the first period, so what is the meaning of first period? It means when we draw the structure of these two elements, hydrogen and helium, we only use one shell. Like if I draw the structure of hydrogen, hydrogen atomic number is 1, atomic mass is also 1. So this is a nucleus of the hydrogen which contain one proton. And when I draw the electron around the nucleus, so there is only one electron around the nucleus. When I draw for helium, it is 2 and 4. So in the nucleus, it contains 2 protons, 2 neutrons. How I work out the proton neutron, that's we discussed in the first topic, that like example, if helium is He, which is written 4 and 2, so A is equals to 4 and Z is equals to 2. So if I need number of neutron, that's equal to A minus Z. If I need number of proton, that is equals to Z. And if I need number of electron, that is Z minus the charge. This is the first topic we discuss. So this 4 minus 2, that's equal to 2 neutrons. Number of protons equal to Z, that's also 2. And number of electrons, Z is 2 minus the charge is 0. So number of electrons are also 2. So when we arrange, the first shell maximum can hold 2 electrons. So you can see there are 2 electrons in the last shell. So why we call there in the first period? Because we are using only one shell, the first shell. There are 7 shells, but only first shell is occupied. That's why it belongs to period 1. For helium, as you can see, for helium, there are 2 electrons in the outermost shell. So if there are 2 electrons in the outermost shell, then helium should be here. But helium is not placed in group 2, it is placed in 0 group or group 8. What is the reason for that? Because the first shell maximum can hold 2 electrons and helium is having 2 electrons. So it shows that helium is having a complete shell. So whenever the complete shell is there, then that element is not placed in according to the number of electron is the last shell. It is always placed in group 8 or 0 group. Is it clear, the concept of the group and the period? Same way as you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So this is the second period. So it's the second period means how many shells will be used? 2 shells. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. That's third period. Potassium, calcium, scandium, titanium, vanadium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, and bromine, krypton. These all elements are fourth. So shows the number of the electron which you use, that represent a number of shells which you use, that represent the period, and number of electron in the outermost shell represent the group number. So group 1, group 2, then group 3. So why we left this part? Why did we did not place these elements in a specific group? So reason for that, why they are not placed in a specific group? Because their number of electron in the outermost shell change or vary. That's why we call this part as a transition metal, because they can sometime lose 3 electrons, 2 electrons. As you can see, sometime we are saying iron is +2 and some compounds iron is +3. What's the meaning of +2 and +3? It means that sometime iron is losing 2 electrons from its shell, sometime it is losing 3 electrons from the shell. So because the number of electrons which they are losing is not fixed, so they are not placed in a specific group, and they are located between group 2 and group 3, and we call that as transition element or transition metals. Look, for groups, lithium is there, group 1. So it has 1 electron and always it will lose 1 electron from the outermost shell. Sodium is there, 1 electron, it will lose. Potassium is there, it will lose 1 electron. So because they have 1 electron in the outermost shell, that's why they are placed in group 1. But why this part specifically, they are not placed in a specific group? What's the reason? So reason is that because if you take example of iron, as we discussed that iron test for the iron sometime is losing 2 electrons. So if it is losing 2 electron, it must be in group 2. But sometime it is losing 3 electron. So if it is losing 3 electron, it should be in group 3. So there is no specific number which this element can lose the number of the electron. That's why they are not placed in a particular group. They are placed between group 2 and group 3. And this region is known as the transition element region, or these elements or metals are known as transition metal. Is it clear? Why hydrogen is placed alone, not in a group 1? There's a reason for that, because these all are metals: lithium, sodium, potassium, rubidium, cesium, and francium. But what is hydrogen? Hydrogen is a non-metal. So it should be here. Some periodic table you will find hydrogen they place here. But because still there's a debate. Why there's a debate? Because when you have elements in the same group, they should have same properties, similar properties. But when you check hydrogen, hydrogen is a non-metal, whereas other are the metal. That's why some of the chemists oppose this position of hydrogen to be here. That's why it is placed alone, not in a particular group. Is it clear? This is the introduction of the topic, the periodic table. Now, what is this staircase line? You can see this staircase. So why it is drawn? Because it shows the boundary between the metal and the non-metal. You can see a periodic table. Actually, your periodic table contains metals, non-metals, and metalloids. What are metals? Normally, metals have a shiny surface. They are good conductor of heat and electricity. They are malleable. The term malleable means you can hammer them into shape. Like if you have a metal, a bar, so you can hammer this metal into shape. So if you can hammer something into shape, what we call that as malleable. And ductile means if you can stretch them. If you have a piece of or a bar of a magnet and you apply the forces, you can stretch it so you can make the wire. So if you can use it to make a wire, we call ductile. So these are general properties of metal. What are non-metals? They have dull surface. They can be solid, liquid, or gas, and they are brittle. Brittle means when you apply the force, you can easily break. We call non-metal. But there are other types which have properties. Some properties resemble with metals, and some of the properties resemble with non-metal. And what we call them as metalloid. So how you can locate using a periodic table, how you can identify whether an element is a metal, a non-metal, or a metalloid. So a very simple concept about identification of metal, non-metal, and metalloid. You can see what we will do. We will draw a staircase. We'll draw stairs, a boundary. So the elements which are below this boundary or on the left hand side, these all are metals. The part which is shown in a green, these are metalloids. Metalloid means they have some properties resemble with metal and some of the properties resemble with non-metal. And on the top of this, the metal, these are known as non-metals. Or you can also learn, you can make a staircase like this as well. So if I draw a staircase, you can learn that element above and below this staircase are metalloid except for aluminum. So boron, silicon, germanium, arsenic, polonium, thallium, these all are metalloid. Metalloid means they have properties, some properties resemble with metal, some properties resemble with non-metal. Is it clear? So you have a periodic table. In exam also you will have a periodic table. So using a periodic table, you should be able to identify the metal and the non-metal as well as metalloids. So you can also learn by this one. If I shade this region, boron, so elements above and below this is staircase. If you draw a stairs between boron and aluminum, so first one, boron is there, metalloid, silicon, germanium, arsenic, tin, sorry, not tin, thallium, and polonium. These all are metalloids. On the right hand side, non-metals. On our left hand side, all are metals. Is it clear how to locate the element, or how to identify an element as a metal, non-metal, or a metalloid using a periodic table? Any doubt in this part? I'll share this presentation with you. If you want to copy anything, you can copy from this presentation as well. After the session, I will share the presentation with you. So using a periodic table, now what you have to go through, you have to learn the trends in group 1, group 7, group 8, and transition elements. So this part you will learn in detail about group 1, group 7, group 8, and about the transition. Rest you will leave, you will not learn in detail, but for these groups you will go in detail. So basically, what is a periodic table? As we discussed, the periodic table can be used to classify the element and predict the properties of element, how they are arranged. And elements are arranged in order of atomic number or proton number. You can see here in this periodic table, hydrogen is placed in a group 1, but in practical, because there's a debate about the position of hydrogen, so some periodic table you will find hydrogen position is at this point. Some periodic table you will find position of hydrogen not in any group, because hydrogen is a non-metal, so it cannot have this, it is not having a similar properties of as group 1 element, which are all metals. That's why periodic table, some of the periodic table you will find hydrogen is not placed in group 1. Still it's a debate, not concluded. So some period you can find the position, different position of hydrogen, but it is always in a first period. So you can see a arrangement of the periodic table, how it is arranged. So group this, it will arrange according to proton number: hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, and calcium 20. So these elements at the bottom also are known as transition element. They are not in a specific group, but in A levels you will learn inner transition and outer transition element. But these all are also transition element. This whole part, this Both are transition. But transition elements are further divided into two classes that you will learn in A levels. The number of every element is representing this number is representing a proton number or number of protons. So I want you to learn for first 20. You can see here hydrogen is 1, lithium 2, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, 14, 15, 16, 17, 18, argon, potassium 19, and calcium 20. It is not a part that you should memorize this for 20 elements, but if you learn these 20 elements, it will make your work easy. Like if you learn atomic number and atomic masses, so you don't have to go through a periodic table again and again for first 20 elements. Most of the compounds which you are or questions which you are solving related to this chapter, you'll find for first 20 elements. So it will be easy to identify the formula of a compound if you learn their atomic number and atomic masses. So elements are arranged in order of atomic number or the proton number, and elements in the same periodic group have the same amount of elements have the same number of electrons in the outermost shell. Like example, you can see it's group 1. So lithium will have 1 electron in the outermost shell, sodium will have 1 electron, potassium will also have 1 electron, rubidium having 1, cesium 1, francium also 1. And you can deduce the electronic configuration of element from their position in the periodic table. How we can deduce? Example, so if I say I have silicon, so silicon, it is group 4 and period 3. This is the first period, second, third. So third period means now how many shells are used. So the silicon in this example, it is group 4 and it is period 3. So we can draw the structure of silicon. How we can draw the structure of silicon? If period 3 are there, like example, this is a nucleus of a silicon. This is a nucleus of silicon. So third period means how many shells will be there? 3. 1, 2, 3. And group 4 means how many electrons in the last shell? It will have 4 electrons in the last shell. So and as we know, silicon is 14 and 28. So it is 2, 8, and 4. So means first shell it will have 2 electron, second shell it will have 8 electron, and third shell it will have 4 electrons. So you can see we can deduce the structure of the element from the periodic table, identifying the group using a group number and the period number. Is it clear, this part? So as you can see, this is a periodic table. A staircase line is there which shows a metalloid, the boundary between metal and non-metal, we have metalloids. So in a periodic table, what we learn, what we, from moving from left to right, like this is the left hand side of a periodic table, this is the right hand side. If I move in the periodic table from left to right, what I will observe? Moving from left to right, the metallic nature changes to non-metallic nature. Like on the left hand side, we have metals, and on the right hand side, we have non-metals. So metallic character, what is the meaning of a metallic character? Metallic character means like substance, the element will be shiny, it can conduct, it will be high density or malleable. And either side of the staircase line, we have a metalloid. Metalloid means which have similar properties, or some properties resemble with metals and some of their properties resemble with non-metals. Then the group number shows the number of electron in the outer shell, and metallic and non-metallic metals. So metals, if a element is a metal, what they tend to do, if we have a metal, they tend to lose electron. If they lose electron, they will form a positive ion. If element is a non-metal, what they tend to do, they tend to gain electron. If they gain electron, what will they will form? They will form a negative ion. So why elements in the same group have a similar chemical and physical properties slightly change? Chemical are same because they have same number of electron in the outermost shell. That's why they have the similar chemical properties. Families on the periodic table. So columns are known as the families. Like this one column is known as one family. This second column is known as another second family. Well, and these families have a specific name. Like example, group one. Group one is known as alkali metals. Why we call them as alkali metals? Because group one, these metals, when they react with water, they form an hydroxide or metal hydroxide. That's why we call them as alkali metals. Same way, group two are known as alkaline earth metals. Why alkaline earth metals? Because most of these metals are extracted from the earth crust. That's why known as alkaline earth metal. Same thing, group 7 are known as halogen family or halogens. Halogen, the term halogen means salt former. Like they tend to form a salt when they react with metal. That's why we call them as halogen. Like sodium fluoride, sodium chloride, potassium bromide, lead iodide. These all are salts. That's why we call them as salt former. And group 8, it was known as inert group, but now it is known as noble gases. Why noble gases? Because unreactive or inert in nature does not tend to react. That's why we call them as noble gases. But you will learn about alkali metals, halogens, and noble gases. Alkaline earth metal, you will not study anything about alkaline earth metals. So first, alkali metals. The first column of a periodic table, which is also known as group 1, but we did not include hydrogen. Hydrogen is a non-metal, so it's not included there, are known as alkali metals. Why they are known as alkali metals? As we know, these elements include lithium, sodium, potassium, rubidium. So why we call them as alkali metal? Like example, if I have lithium and I add water, so lithium plus water, what it result? It result in a formation of lithium hydroxide plus hydrogen. So hydroxide is formed. If hydroxide is formed, means the solution will be alkaline, or the pH of the solution will be more than 7. That's why we call them as alkali metals. They form alkali when they react with water. So sodium mixed with water, what will be the result? This will result in a formation of sodium hydroxide plus hydrogen. Potassium is there, I mix with water. What will be the result? It will form potassium hydroxide plus hydrogen. Now, what is the observation when this reaction occur? Like potassium is solid, water is liquid, alkali is aqueous, and hydrogen is gas. What are the two observations when this reaction will occur? Two observations. Yeah, bubbles or effervescence because of hydrogen, that's one thing. And the mass of the solid decrease. Solid dissolve or solid mass decrease because this is potassium, so its mass will decrease, and the hydrogen is a gas, so we will observe bubbles. And these metals, not their compound, they're metal. Like example, if I have a sodium metal, these are also known as a soft metal. So why they are known as soft metal? Even I can use a butter knife to cut these metals into two halves. So we can easily cut these metals. That's why they are also known as soft metals. Generally, the metals have hard surface, but these metals have a soft surface, so easily cut by a knife. So these are some properties of alkali metals or group 1. Group 1 metals, they have very low density. Density means how many particles in a unit space. So they have very low density, therefore they float on the water. And density increases as we go down the group. You have to learn this trend. Like for group 1, what happened to density as we go down? The density increases as we go down the group. So when we compare, like we have the periodic table, so you can see lithium, sodium, potassium, rubidium, cesium, and francium. Which one you think will have the highest density in this group? Which one you think will have the higher density in this group? So francium will have the higher density and which one is having the lower density or smaller density in this group? Lithium is having a smaller density. So you have to learn this trend, that what happened to density. There is a reason for why the density increases, because there is more mass. As greater mass, that's why the density is increasing. But they will not ask the reason, just the trend is important. So they will ask like which one having the higher density, or going down the group, what happened to density of group 1 element. And they have a shiny or a silvery surface when freshly cut, but quickly tarnish. Why the surface tarnish? Like when you cut them, it is shiny, but because it is highly reactive, so they can react with oxygen, and the surface quickly tarnish. Means it will no longer remain shiny. They have low melting point compared to other metals. They have low boiling point. And as we go down the group, the reactivity also increases, become more reactive. What is the reason why as we go down the group, the reactivity increases? So down the group, what we observe the reactivity increase. What is the reason for that? As you can see, if I draw the structure of each element, I have lithium. Lithium is I'm not drawing the nucleus, I'm just drawing the shell, the last shell. Lithium is having, I'm just drawing the shells, not the nucleus. Lithium is having 2 shells and the last shell 1 electron. Sodium is having 3 shells and in the last shell there is 1 electron. Whereas potassium is having 4 shells and in the last shell there is 1 electron. So you can see that electrons are far away. Electrons in potassium is far away as compared to that of sodium, and in sodium is far as compared to lithium. And these are metals, they tend to lose electron. To react, they tend to lose this electron. So which one you think can lose electron easily? Lithium, sodium, or potassium? Which one of them can lose electron easily? So potassium, because of its greater size, electron is far away from the nucleus, so it can lose electron easily. So as it can lose electron easily, potassium will be more reactive than sodium, or sodium will be more reactive than lithium. So as we go down the group in this, what we observe down the group, the reactivity increases. So which one you think is more reactive, lithium or francium? Which one is more reactive? So francium is more reactive. Why? Because it's having a greater size. Electron is far away from the nucleus, so it can lose electron easily. Again, you don't have to learn the reason. They will not ask the reason why francium is more reactive. You just have to learn the trend. But there is reason is that because electrons are far away from the nucleus, so weakly bonded element can lose its electron easily.
Sir?
Yes.
Sir, you said that the densities are low in the alkali metals.
Yeah.
So even francium, it floats on water?
Density is low for, and as we go down the group, the density is increasing. The first 2 elements, first 3 elements having a density lower than water, so they float on the surface of the water. The other elements, their density is higher than water, so they sink.
Okay, sir. Thank you.
So density is increasing. First 3 having, when we compare with water, they have lower density. But as the density is increasing, the elements which are at the bottom, they have higher density than water, so they can sink, or it sinks. So the melting point, as they have low melting point, the density increases as we go down the group. Reaction with water, so they react with water and form an alkali, and hydrogen gas is there. And as we go down the group, the reaction become like vigorous, and then violent reaction is there, an explosive reaction as we go down. And they tend to lose electron and form a positive 1 ion. The reasons, you don't have to learn the reason. This was about group 1 or alkali metals. We'll discuss some questions related to this part about alkali metals. Just a minute, I will share with you the questions. So you can see this periodic table, and in this periodic table, on the left hand side, so in this periodic table on the left hand side, we have more metals than on right. And as we go down, they become more metallic. What's the meaning of becoming more metallic? Means they tend to lose electron easily. So which side they are more metallic, left or right, and top or bottom of the group? So what could be the answer? Yeah, A is the right answer, because on the left hand side they are more metallic, and as we go down, they tend to lose electron easily. So A is the right answer. Rubidium is a group 1 metal. Non-metal tend to gain electron. Metals tend to lose electron. Rubidium is a group 1 metal. Which statement about rubidium is not correct? As we go down the group, the melting point increases as we go down the group, okay? Sorry, as we go down for them, the melting point decreases. The density increases, and the reactivity increases. And you have this so you have these elements, lithium, sodium, potassium, rubidium, cesium, and francium. Which statement about the it's not correct? It has higher melting point. As we go down, the melting point decreases for group 1. It has 1 electron in the outermost shell. That's true. It reacts vigorously with water, means because as we go down, reactivity increase. It reacts with chlorine to form rubidium chloride. That's also true. So which is not true? It does not have higher melting point. It has lower melting point. What is the reason why? What is the reason why the melting point of rubidium is smaller as compared to that of lithium? Look, as we discussed the metallic structure, what is a metallic structure? Is a positive ion and the sea of electron. That's called a metallic structure. So lithium positive ions are smaller in size. So there are more ions in a unit space. So they are held together, or strong force is there as there are greater number of ions, positive ions in a unit space for lithium. These are all the positive ion because these are metals. So metals have positive ion and the delocalized electron. So there are a lot of ions. So they have strong, greater attraction between the electrons. That's why high melting point for lithium. But when you take rubidium, because rubidium size is bigger, so the positive ion which is formed by the rubidium will have a greater size. So few ions will be there within the structure. So if few ions are there within the structure, then which one you think will have a strong attraction within the structure? Because more ions, so stronger attraction, high melting point. Few ions, so weaker attraction, so that's why it will have low melting point. So as we go down the group for group 1, the melting point decreases. Is it clear? Discussion. Which statement about elements in group 1 is correct? Which statement about group 1 or alkali metal is? As we go down the group, the reactivity increases. A is the right answer. Look, hydrogen is evolved when they react with water, because when alkali metals react with water, they make a solution alkaline and hydrogen gas is released. The ions of group 1 element have -1. That's wrong. It is +1. Sodium is more reactive than potassium. No. As we go down the group, the reactivity increases. So potassium is more reactive than sodium. Solid sodium is a poor conductor. All metals are conductor. That's a common property of all metals. They all conduct. So that's wrong. A is the right answer. What is not a property of group 1? Yeah, that's right. C is the correct answer. They are soft and can be cut by knife. That's true. They react when exposed to oxygen in air. That's true. They produce acidic solution. No, they produce alkaline solution when they react with water. And they react rapidly with water to produce hydrogen gas. So C is not a correct property for group 1 element. Question 31. The part of a periodic table is shown which element has 2 electrons and 3 electron shells. Look, B and C have 2 electrons. That's true. But 3 electron shell means period 3. So group 2 and period 3. Group 2, B or C can be answered, but period 3 you can see. That's period 1. That's period 1. This is period 2. And this one is period 3. So that's why it is C is a right answer. So these are some questions related to alkali metals. So we'll continue this topic tomorrow and discuss about group 7 halogens and group 8 and the transition elements. Any doubt related to this part or this class? Okay, so I'll end the session and share the recording with you.